If you're taking AP Environmental Science, you're in the right place. We're going to be going over Unit 6, Part 1. I'm joined by Jordan from Apes versus Everybody. Jordan, how are you doing tonight?
I'm doing great. It's light out for the first one of these in a while, so it's a great feeling.
Wonderful. Jordan, I'm going to turn it over to you. You can help us figure out what we're going to be doing for this year's exam for Unit 6.
Absolutely. Yeah, we're going to get right into it here and talk about energy. Energy is a huge concept that we need to be able to answer multiple choice questions about. We need to be able to write about it. We need to be able to do a lot when it comes to Unit 6 because it's energy, and that's just a huge, huge part of APES. So welcome. This is AP Environmental Science Exam Review, hosted by Marco Learning with the APES Everybody. That's me. And so we're just going to get right into it. As a reminder, you always want to check out Marco Learning on their socials if you don't already. Great TikTok content. I am heading in the TikTok direction. I'm not there yet. Each week I take a step closer. I'm looking at sort of mounts or like tripods for my iPad. So getting closer, but it is coming soon. I've been told I need to get there. So what are we going to cover today? We're going to look at common FRQ mistakes. This is my favorite way to get you guys ready for the exam because there are some common pitfalls that students make over and over and over again. And I really want you to avoid those mistakes. I like to call them the Achilles heel that students have. And so I'm really trying to point out what are the mistakes you might make ahead of time. If you already know going into the exam the mistakes that past students have made, the hope is you can avoid them. Then we're going to talk about Unit 6, specifically Part 1, which is going to focus really heavily on fossil fuels and other non-renewable energy sources. And then we're going to go through some Goto FRQ answers. So how can you really make sure that you have in your back pocket ready to go some surefire, APES content to write about, some APES knowledge, as I like to call it. And then we'll wrap up very briefly with some study resources. And I'm going to give you one tip that I think can really elevate your FRQ rating. So that's what we have today. This content has been gone over quite a few times in these videos, so encourage you to check out one of the older APES review videos on the Marco Learning channel if you want more of an explanation here. But these are the exam dates. You need to make sure you talk with your school to figure out when your date is because it's different for everybody. But these are the formats. The format for the exam in terms of what it actually looks like will not change between those 3 administration periods. It will be 80 multiple choice questions in 90 minutes, and that will be 60% of the exam. The FRQs will be 3 FRQs, 70 minutes. And the nice thing is we have some clear guidelines for what those FRQs will look like. We know for a fact that one will be designing an investigation. If you're interested in that, we focused on it in last week's video. I will also be doing a full detailed video on each of these 3 FRQ styles in the future. So if you're interested in really strengthening your calculation-based FRQ, we're about to work on that today. If you're interested in really strengthening your design and investigation FRQ, which is experimental design, last week's video looked at that, but I'll also be producing some very specific FRQ videos on these in the future. Big change to note, exams are not open book. So you're not taking exams open book this year as they were last year. So if you don't already have the Write Like a Scholar handout here, like I like to call it past verb sheet, kind of helps students know how to annotate it. That is a great idea, a great thing to get on top of there and use. So I will just pop that link into the chat so that you guys can check that out if you haven't already. It's going to be in the link tree, as are really all of the resources we will use here today. And so common FRQ mistake number 1. What is the common mistake that students make? It is leaving out steps in a process. So many times, if your prompt goes beyond just identify, like if it goes into describe, explain, propose a solution, justify, you need to link your answer back to the prompt. And oftentimes you need to connect the dots. And so you need something that's kind of step by step. You're not just leaving your answer out there. You are actually connecting dots. So let's look at an example. Describe how biomass can be used to generate electricity. So students may write something like wood can be burned to produce heat, which can be used to generate electricity. That's not factually wrong, but you left out a key element that you need to earn this point. So if we look at the right hand here, we have wood can be burned to produce heat. which can be used to convert water into steam. The steam can turn a turbine, which powers a generator. So what's in green there is what was missing. On the right, we have earned a point. On the left, we've left ourselves short. We've done what I call stranding the point. When you leave out a step in a process, you strand the point and you don't earn it. So even if you maybe knew how biomass can be converted into electricity, if you didn't put that critical step, you're out of point. There's only 30 points possible in the FRQs, and so everyone is critical. You need to earn them. I'm not going to go through every single one of these processes here, but these are 4 processes that I frequently see students miss steps on, meaning they kind of have the beginning and the end, but they're not able to actually walk through them. So electricity generation, we're going to focus on this really heavily in today's video. I'm not going to go over here because we have a whole slide dedicated to it coming up in a bit. Eutrophication is a big topic. You need to be able to understand that eutrophication is excess nutrients, specifically nitrate, phosphates, or other forms of nitrogen. And it runs off into a water source. So it could be from a farm, from their synthetic fertilizer, wastewater treatment plant. But the bottom line is it gets into a water source, and that causes this algae bloom on the surface. Algae blocks the sunlight. Now the plants beneath the surface die, and bacteria break them down and use up the oxygen. So we have oxygen crashing, and now we have what's called hypoxia, hypo for low, ox for oxygen, and we have dead zones. Hey, Kimmy, thanks for tuning in. Thanks for tuning in as well, Gaming with Mr. X and ABC123. Appreciate seeing you guys in the comment section there. And then 2 other topics that we will be covering in upcoming videos would be photochemical smog and acid rain. Again, not going to touch on the exact steps here. You can check this slide out, pause it, and kind of walk through it here. I really want to focus on energy today, but these are 4 steps or 4 processes with many steps that students often make mistakes with. And so this slide, in fact, here would be a great thing to study from. So just taking a screenshot of this and really seeing if you could walk through, especially using the emojis, really helpful way to prep. So mistake number 2, what is the second thing that students do that costs them points they should earn, or strands points? That would be not fully describing the solution to a problem. So we know for a fact, for sure, the College Board tells us we will have to describe a solution to a problem or propose a solution. And so when you do, don't cut corners. What I mean is don't just say the solution. Don't just say people should stop burning coal or people should stop driving their cars. It's just too vague. We need to be a little bit more precise. So here are some things you can do to fill in the gaps. How will this be implemented? Who will implement it? Or where will it be implemented? You don't need all 3. You don't need to say the United States government will do it by passing a law specifically in Louisiana. That's a lot of detail, but we need some detail there. So if we look at an example here, describe one strategy that can be employed to reduce the flow of nutrients into the Gulf of Mexico. You might think, oh, why don't we plant some trees? Trees will, kind of take up some of those excess nutrients in the runoff, and we won't have them flowing into the Gulf. But if you just write more trees should be planted to soak up excess runoff and use the nutrients in it, you've left out some critical details, which are where. I think we can all remember that GIF of that guy. Well, I guess it's a whole video, but he's like, where, or why, the pastor, right? And so think of that kind of like, why is this happening? Where is it happening? How is it happening? And so if we just specify and we say more trees should be planted along the banks of the Mississippi River to absorb excess runoff from the farms, preventing the nitrate and the runoff from entering the Gulf. We've been specific now about where this is happening. This elevates our answer, and it's now worthy of earning a point. I want to check into some comments here we have coming in. Night Creation, again, a very dedicated APE scholar here who tunes in time and time again, has a question. Is the AP Environmental Science exam digital as well? I cannot take it in person. Yes, the answer to that is yes. You would need to check in with your school, though, or whoever's going to order that exam for you, so your school's administrator. My class just finished up Unit 5, and I'm not sure if we'll finish up content before the AP exam. I'm taking the June 11th session. So ORPICS, you could squeeze it in. That's really going to be tight, though. I don't know if I'd say I'm behind in my class. We're like just behind where would be ideal, and we're halfway through Unit 8. So I would certainly recommend watching the videos on my page, as well as asking your teacher to assign the AP Daily videos on AP Classroom. Those are super helpful, and I would really try to cover some content on your own ahead of time, because just being done with Unit 5 is not on a great pace to be done with everything by June 11th and still give you time to review. Calvin, you'd have to reach out to your school, and whoever your AP administrator is there could get you signed up. There may be a late fee, but I believe they can potentially still sign you up. But that's a question for your AP coordinator at your school. Yes, that is a good place to be. Just finishing up 8, that's fine. Like I said, it's like a smidgen behind where it might be nice to be depending on your testing session. But being in Unit 8, just finished Unit 9. I'm sorry. Yeah, you're golden. You're golden. I thought you said just starting. Yeah, that's a great place to be. So let's look at a second not fully described solution here. When you describe a problem, again, you just can't cut corners. You can't just throw the solution out there and say people should just drive their cars less. That's just not realistic. How are they going to drive their cars less? What is going to prompt them to do that or motivate them to do that? So think of our who, how, where. And in this case, we can fill in those details with what we see in green. The city of Los Angeles can invest in more bus routes. If there are more bus routes, people may be willing to drive their cars less. That might mean there are fewer NOx emissions being released, but then also we should connect back to photochemical smog at the end, which combine with VOX in the presence of sunlight to form smog. So really key to link back to your prompt. Okay, here we go. Common mistake number 3, math. You need to be able to do math on the APES exam. You can use a calculator. That has changed from previous years. There was no math on last year's because they were only FRQs, and I think College Board was maybe concerned about people being able to collaborate and share answers more easily on math. So there will be math this year, though. You get to use a calculator. The good news, though, is that you're not left up in the air wondering if you'll have to do long division or factor a polynomial or calculate the area under a curve. It's pretty clear what the questions will be focusing on. So what I've put here are 6 topics that the questions that involve math could cover, but then I've highlighted in yellow what have the recent FRQs covered. And the most recent FRQs in APES have all focused on percent change and just finding a percentage of a number, and then unit conversion or rates. And when I say rates, I mean something like, if we extract 10 million barrels of oil a month and we want to get to 2 billion barrels, how many months would that take? Things along that line where you're given a rate, if China consumes this many kilowatt hours in a year, how many kilowatt hours would they consume in a day per person or something? So moving back and forth. ORPICs, you will not be given any formulas. So it is helpful to certainly know the doubling time, which is 70 divided by the growth rate, expressed as a percentage. That would be the years for the population to double. You may have to do half-life. You may have to calculate population growth rate, which is CBR minus CDR times 10. And you may have to calculate productivity. The reason I say may is it is not totally clear that the most recent FRQs are heading in this direction. The most recent FRQs focus heavily on percent change, percentages, and unit conversion and rates. So I can't promise, and no APES teacher knows for sure what the math will be, but we can tell you that when we look at the most recent FRQs, they're all focused on percent change, unit conversion, and taking percentages. Okay, here's how to do percent change. This is a super helpful slide. I will get a math section going on my link tree at some point, and that way you'll have this resource if you want to look back on it. But this is a really helpful thing. You may even want to write these down or get a screenshot here, but just super helpful. Okay, so night creation, good question. That's one reason they're sticking to percent change. typically is that it's pretty easy to write this out just in one line, like using a slash or dividing sign. And I think they're even building in some math capabilities as well. So those will be options as well. Yeah, it is a little bit more complicated. So we'll have to see. They're going to put out a practice like module, basically a simulation of the exam that we can use to get ready. And then Batul, it's just kind of out of the scope of the College Board to totally regulate what people have at home and in class. So that's unfortunately just a drawback of exams this year. Okay, so let's take a look at percent change. Very high likelihood that there is a percent change question on your FRQ. Again, this has been on recent FRQs. It's been on practice FRQs. It looks to be the direction they're going. Yeah, percent change. We're going to break it down, Samantha. So the hope is that you leave today feeling good about percent change. So you need to have this formula down. It's the new value minus the old value over the old value. And then you're going to multiply that by 100% to turn that into a percentage. You're going to get a decimal when you do that division problem. So that's really important. You can't forget to multiply by 100. That will express as a percentage rather than as a decimal. So let's take a look at this question. This was the 2017 FRQ. Calculate the percent change of elephants in Africa from 1970 to 2000. So in 1970, which is our old value, and if you're wondering, how did we know 1970 was our old value? Well, it's earlier than 2000. It's older in time. It's where we started. So 1970, we had 2 million elephants. And since our equation is new minus old over old, we have 400,000 elephants in 2000. So we're going to plug in 400,000 at the beginning minus 2 million all over 2 million. And that's going to equal negative 160,000 divided by 2 million. And that's basically just 16 divided by 20 or 1.6 divided by 2. And that's going to be negative 0.8. We have to remember, though, to carry down that times by 100. So negative 0.8 times 100 is going to be negative 80. And if the number is negative, we know it's a decline. So the elephant population decreased by 80%. And so again, if you can just remember new minus old over old, that will get you there. New minus old over old multiplied by 100. Yes, we are about to get into Unit 6 material, Liam. Great question. So again, highly, highly recommend knowing how to do percent change. I would take a picture of this slide or just check my link tree later. I'll make sure that there's math slides in there for you. Another thing you may do is just a percentage, meaning here's a number, figure out a given percent of that number. So we have a different question here. If there's a 20% decline in the elephant population between 2015 and 2022, calculate how many elephants will be left in 2022. And so the way I think through this is we look at our starting number is 2015, that's 600,000. So we start with 600,000 in 2015, and we know there's a 20% decrease. Now you could multiply and figure out what 20% of 600,000 is and subtract it from 600,000. But I think it's far easier to think through, well, if there's a 20% decrease, that means there's 80% left. And so then all we're doing is figuring out what's 80% of 600,000. And to figure out what a percentage of 600,000 would be, you're going to multiply by 0.8. And so multiplying 600,000 by 0.8 tells us 480. And then we should also throw units on there at the end. So there's our unit. So again, highly recommend percent change and just percentages. It seems to be very likely that these will be on the exam in terms of the types of math you'll have to do. Just going to stop for a quick second to see if people have any questions in the chat. Also let you enjoy a meme here, and then we'll be on to Unit 6 content.
Real quick, Jordan, I just wanted to hop in and say hi to everyone and thank everyone for joining. We have a nice group in here asking amazing questions. If you are enjoying this video, press that like button. Definitely let us know how we can help you. Again, stay in touch with us on the Marco Learning Instagram page, on our TikTok page, here on YouTube, because there's lots of information that we're putting out, especially as we get closer to this exam. So I just wanted to remind you all, keep asking these great questions, and on behalf of everyone at Marco Learning, thank you guys for joining. It's great to see, by the way, with Night Creation, Samantha, Liam, a bunch of people that we've also had a chance to see before. So yeah, I'll turn it back over to you, Jordan, and we'll keep going.
All right, thanks, John. Great question, Batul. No, you've got to have the units, and typically math points are trending in the direction of all or nothing, so 1 point or 0 points. In the past, they have offered 2 points, one for correct setup, one for correct execution, but you really want the units on there. Okay, very quickly, renewable versus non-renewable. Biggest takeaway here is that we need to use the term renewable, and we need to know what it means. Things you do not want to do on an FRQ. I like to tell my students you can basically kiss the point goodbye if you use the words green energy, eco-friendly energy, clean energy. Not things that you want to do. So make sure that you are writing about renewable resources from the standpoint of something that can be replenished naturally if it's used at or near the rate of regeneration. So wood is a great example. Wood is renewable with an asterisk only if we reuse it at about the rate it regrows. If we use it way faster than it regrows, it's not renewable anymore. And so it is depletable. Things though like sun and wind and hydro, those are renewable and non-depletable. They don't run out. So if I put out a solar panel, there's not less sun because it went into the solar panel. Great question, Batul. You should try to include the units in the setup, definitely. Great question, Orpix. 4 answer options this year. So questions will have 4 answer options. Okay, very quickly before we go on, non-renewables just mean they exist in a finite amount. So they are not going to regenerate on a human timescale. So there's limited amounts of them left. And we can see here the number of years left of different fuels. And that's because they take millions of years to reform. So we're not going to get more oil returning to the ground on a human timescale. So if we take a look here at development, development has a huge factor on energy use. So developing nations are going to rely more on subsistence fuels. These are things like biomass and charcoal. And they do that because they can be easily gathered from around their homes. So sometimes they're even free. If you go out into the forest and cut down wood or gather dried animal waste or peat moss, things like that, you can burn it to heat your home or to cook. And it doesn't really cost you any money. And so again, in developing nations, really prominent. Developed nations, though, are going to use what are called commercial fuels. So these are fossil fuels, coal, oil, and natural gas. And so a country is getting these typically from large corporations that harvest them, and then it goes to a power plant so that when you turn on your light, you have electricity. So we need to understand the difference between the subsistence fuels and commercial fuels. Another big fact that we have to know, an important thing, is that developed nations are going to use more energy per capita. And that's because they're more affluent. They have more money. So they have more cars, larger houses, more gadgets. And so that equals more fossil fuel combustion. Take a look at this graph here, and we can see this positive correlation where the higher a country's per capita GDP, meaning the higher their per capita wealth or the money that they earn, the higher their per capita energy use. And that term per capita, this is like a write like a scholar kind of opportunity here. Make sure you know that per capita means per person. And then also make sure that you understand that a country can use more energy per capita, but less energy overall. And China and the US are a great example. China can use more total energy than the US, but it uses less per capita per person. And that's because there are over 1 billion people in China, but there are only maybe 360 million in America. So, China has a much larger population, so it uses more total energy, even though the US uses more per person. All right, this slide is chock full of info. I want to touch on each of these major forms of fuel, and then we're going to get into them a little bit more specifically. So coal, we need to know has a 100 to 150 year supply. It's the most abundant. It's our #1 electricity source. So globally, more electricity comes from coal than any other source. It's the cheapest, it's the most available fossil fuel, but it's the highest polluting. So it has some drawback. When I say highest polluting, notice I'm not saying most air pollution, because pollution, not a thing. Pollution is just an idea. We need to have pollutants, right? Specific compounds. So it releases the most carbon dioxide, the most NOx, the most SOx, and the most particulate matter. So even though it's cheap, widely available, and a great, great in the standpoint that countries use a lot of it to produce electricity, it's not so great from an environmental standpoint. It's the most polluting. When we look at natural gas, it's going to be used primarily to heat homes and to generate electricity. It's the second electricity source behind coal. Then when we look at its advantages, it is less polluting, and in fact, it's the least polluting. Sometimes people say it's the cleanest, air quotes, natural gas, but we don't want to call it clean. We want to say that it releases less or fewer pollutants, and those are carbon dioxide and NOx. And then what's really nice about natural gas compared to coal is it releases no SOx, no particulate matter, and no mercury. And so that's a huge benefit. One drawback is fracking. It is harvested via fracking. That takes a lot of water. We'll take a look at fracking in a second. Oil then has roughly a 50-year supply, pretty similar to natural gas, and it is primarily used for gasoline. So it powers vehicles, and it also makes diesel fuel, though, which powers large trucks, and then it's used to make plastic. So that's one kind of like apes, hashtag apes knowledge point that we need, that some folks overlook. Oil does go into most plastic products as well as asphalt. So the bitumen, which is essentially tar that we use on our roads. So oil is used in a lot of products, not just for energy. It's medium polluting compared to coal. It releases all of the pollutants coal does, but in lower amounts. And then it's harvested by drilling wells into the ground and just pumping the oil out, or by tar sands. And we'll get into that shortly. What I'm going to do today for the sake of time is actually skip over wood and biomass, because we are covering these in next week's video. Yeah, great question, Batul. I do plan to do some more live reviews in the future. I haven't worked out a schedule. I certainly haven't planned that out like to a T, but I definitely do plan to continue doing some reviews. So just stay tuned to the Apes versus Everybody and the Marco Learning channels, both on YouTube and on Instagram, and you'll be sure to get more info on that. All right, this is a super critical slide. Oftentimes students forget the steps of electricity combustion or electricity generation by combustion, and they lose points. And so if you understand all of these steps, this is maybe the most important diagram in Unit 6, and like one of the top 5 diagrams in all of APES. And I'll go through it here in a second. So again, just a really critical diagram. It's so critical to understand this, because if you can remember how heating something up, basically how producing heat can create electricity, you now remember how coal, oil, natural gas, biomass, trash, nuclear, and geothermal energy work. You even kind of remember how hydro and wind work. The turbine generator electricity sequence is huge. If you can get something to spin a turbine, that turbine powers a generator, that generator creates an electrical current. Now you have electricity. So we can replace the combustion step with a lot of things. We can burn, again, coal, oil, natural gas, biomass, trash. Really anything that's carbon and hydrogen based will burn. And if it burns, you have heat, and you can turn water into steam, and that steam can spin the turbine. The thing that's neat, though, is you can do this with water, and you can do it with air. So a wind turbine, you would just replace burning and steam with wind. Wind spins the turbine. And when we talk about hydroelectric, it's a dam building up water pressure that spins the turbine. When we talk about tidal energy, propellers underwater, essentially, turbines underwater, they generate electricity due to the turbine powering the generator. So again, I can't say enough about how critical this slide is to understand. And I'll leave it up here for one more second while I check in on the chat. Good question, Batul. You just have us on YouTube. Yeah, so make sure you follow both accounts on YouTube, and I will be sure to do some sort of announcement for APES review in April and in May. And then Maya, I've definitely considered adding practice multiple choice. I think that what I would like to do is add multiple choice questions to my Instagram story every day with the answer keys posted shortly after. I've seen AP Bio Penguins. She's just an awesome review account. And I think I want to follow that kind of model. So that's probably how I'll try to work those in, Maya. All right. Coming into the home stretch here, a couple more important things to go over, and then we're going to get out of here, and I'm going to give you some tips that I actually want you to practice right away, because if you try to put some of these FRQ skills into practice right now while it's fresh in your mind, I think it's super helpful. One thing that APE students struggle with sometimes is what is crude oil versus gas versus petroleum. So crude oil and petroleum are the same thing. They are what comes out of the ground. And then they're converted into gasoline, which goes in your car, plastic, diesel, jet fuel, motor oil, and bitumen, which goes into asphalt for roads. And that's done through something called fractional distillation. Basically, you heat it and the different hydrocarbons move up a column and separate out based on their densities. That's a little bit deeper than you need to know, but you really should know that crude oil becomes all of these things. Then I want to take a quick look at fracking here. So in fracking, we are going to pump water down a well, and that water is going to have a bunch of things in it. It's going to be sand, detergent, acid, salt. That's going to be pumped into the ground, and it's going to fracture the rock. So it actually cracks the rock open, and the natural gas that's trapped in there is going to flow out. Now, this is often done in a sedimentary rock like shale, where that natural gas is found, and then it flows up the water or up with the water, and it's collected in this collection mechanism at the top, and it's transported. But an issue we need to know is water contamination. Two different ways that fracking can contaminate water. You could have a blowout. So the well casing itself, this cement tube essentially, could break and the water could leak into the water table. Now that could be methane. It could be detergent, acid, salt, any of the things in the fracking fluid. But it is also stored on land in either chambers or sometimes even ponds. And if those ponds overflow, now they can run into surface water or seep into the ground. So some big problems with fracking when it comes to water specifically. And then very briefly, just want to touch on some of the impacts of mining. So coal mining, or any type of mining really, but since coal is primarily mined, just by surface mountaintop removal or surface mining sometimes, you're going to get a lot of soil erosion. So the soil is loosened, the roots of the plants are removed, and that removes the soil. It can just wash down, the mountainside. We can get acid mine drainage. We have fossil fuel emissions just from the machineries themselves, or from methane that's also trapped with the coal that can be released. And then of course, habitat loss. Anytime you clear out space to set up a mine shaft, to build roads, to get drilling equipment in, you have destroyed habitat. And then before we talk about some resources that I actually want you to hop right on today and take a look at right now while it's fresh in your mind, I want to give you 3 go-to FRQ answers related to energy. So if you have to come up with an environmental problem, and we know that you will on one of the 3 FRQs. So if you have to come up with an environmental problem, great potential problems would be air pollutants. Notice I said air pollutants, not air pollution. Pollution is an idea. Pollutants are specific compounds. They are point-worthy APES answers. You never want to write about pollution in APES. You want to write about pollutants. So fossil fuel combustion for electricity specifically releases NOx, SOx, and particulate matter. Those are all pollutants that are produced. When you get to Unit 7 and you start to learn about atmospheric pollution, you'll know that NOx and SOx can contribute to acid rain. NOx and VOx in the combination of sunlight can contribute to photochemical smog. So you have all these secondary environmental problems as well. Climate change is a go-to answer. You really need to be able to explain the basis of climate change and relate it to fossil fuels. So when we burn fossil fuels for electricity, we release CO2 that warms the atmosphere because it's a greenhouse gas, meaning that it traps heat and radiates it back down to Earth. Now we are increasing the rate of global climate change. And then finally, habitat destruction. This is kind of like an eights in the hole answer that you can use for agriculture, mining, fossil fuel mining more specifically, urbanization, road construction. Almost any development that humans do will lead to habitat destruction. So those are three go-to answers that are super good to have in your back pocket when it comes to energy. So we are wrapping up now. I'm going to just send you off here with a resource in a second, and then we will be, again, hopefully taking a look at that resource and doing some practice right away here.
Great. Thank you so much, Jordan. Everyone, if you guys have questions, let me know in the chat. We can also, if you are watching a recording of this event, you can post those questions in afterwards. I'm going to go ahead and actually take this off. And again, remember everyone that we have hosted a couple of these reviews. There's been three already, three other reviews. This is the fourth.
Yeah.
On our channel. If you have not yet signed up for Jordan's channel, I'm going to take you there right now and screen share. This is the place. Tell us a little bit, Jordan, you've shown us before. Tell us what we're going to see on this channel and why we have to subscribe to it right now.
Why do you have to subscribe? So far, it has 95 of the 99 topics that are on the exam. It will have all 99 very shortly. But in short, it has all of the content that you need. Now, when I say content, I mean like the facts, the hashtag apes knowledge. But it also has some of the writing like a scholar videos where you can actually see how should I write FRQs? How should I go through, bit by bit and actually break that FRQ down and then really have success on it. What I plan to also do soon is create 3 videos, one for each of the FRQ format.
Wow,
we know
that's
you'll have
great.
to design. Yeah, and part of the reason is I see students really struggle with designing an experiment. And if you really know how to do it, frankly, it should be kind of an easy point or a handful of points. Same thing with the math. People worry about the math. Oh, I'm not really confident about math. If you know how to do percent change, if you know how to just work with percentages, there's a great chance that you're going to have like 3 or 4 easy points where you don't have to remember apes knowledge. You just have to be calm and execute the math. You get a calculator, so you don't have to worry about, actually carrying the digits wrong. You're punching in your calculator, and if you know how to tackle percent change, again, the goal is for you guys to go into these FRQs like 3 or 4 point floors, kind of where you feel confident. I can get the experiment points, I can get the calculate points, and then I just have to earn some of these, explaining a problem or a solution points.
Great. And Jordan, I've posted in the chat that link to the College Board's past questions.
Oh, perfect.
I'm posting a link to your channel that will go here. And I'm posting a link to your Instagram page. All great resources that we want you guys to have on whatever platform you're using. I've just been leaning over my computer, typing all those in. Thank you so much, Jordan. Thank you everyone for being such a great group. Again, if you've enjoyed this video, press that like button, subscribe to our channel, and be in touch with us. We're always here to help.